In this section, we will see the chemical properties of alcohols. The first reaction is reaction with sodium. If a mole of sodium is dropped into some alcohol, it will react steadily to give off the bubbles of hydrogen gas and leave a colorless solution of sodium alkoxide. The reaction occurs on the bonding of oxygen and hydrogen, where the H plus is being replaced by Na plus ion. One of the uses of this reaction is to dispose a small amount of sodium safely. Esters are produced when a carboxylic acids are heated with alcohols in the presence of an acid catalyst. The acid catalyst is usually the concentrated sulfuric acid. The esterification reaction is both slow and reversible. The equation for the reaction between the carboxylic acid and an alcohol, where the R is the alkyl group, it can be the same or different. So, for example, if you were making an ethyl ethanoate from ethanoic acid and ethanol, the equation would be as following. In this reaction, ethanoic acid, which is our carboxylic acid, will lose the OH group, while the ethanol, which is our alcohol, will lose the hydrogen. This will lead to the formation of a water as our side product, and the carbon double bond O will make a bonding with the oxygen here. The third reaction is the dehydration of alcohol. We had seen this reaction in chapter 5.2. In this reaction, alcohols will undergo elimination reaction where we are going to eliminate water. Okay, so this water comes from the OH group, okay, and also the hydrogen from the adjacent carbon. So in this reaction, alcohols will be converted into alkenes. If we have more than alkenes as our product, remember we have to follow the Sazaf rule in order to identify the major product. Okay, so Sazaf rule states that in elimination reaction, major product is the most stable alkene, commonly most highly substituted alkene. Next, we have a nucleophilic substitution reaction, where in this reaction, it's involved the conversion of alcohols into haloalkane. If you can see here, we have 4 different types of reagents that can be used in order to produce an haloalkane. Okay, the first one is the hydrogen halide, where as here, it can be chlorine or bromine. Alright, so if you use HCl, hydrogen chloride, okay, the alkyl halide here, the halogen here will become our chlorine. Okay, if you use bromide, so it will become Br, bromine. Okay, so the side product, okay, if you use the hydrogen halide, the side product will become the water. Next, we have phosphorus trihalide. Okay, so here X, it can be Cl or Br. So if you use PCl3, the phosphorus trichloride, okay, the halogen here will become Cl. Okay, the side product is the phosphorus acid, H3PO3. Okay, and then we have PCl5, phosphorus pentachloride. Okay, so the side product is phosphoric trichloride or POCl3 and hydrogen chloride. And last but not least, if you use a thionyl chloride, SOCl2 in pyridine, we will get a sulfur dioxide and hydrogen chloride as our side product. So if you can see from this example, okay, so even though we use a different reaction, okay, kita gunakan reaction berbeza, but then the reaction is still the same, okay, where we are going to replace the OH group with halogen. Okay, depends on apa reaction kita pakai lah. Okay, and if you can see here, the side product is differ. Okay, so kena hafal lah. Okay, you have to memorize the side product. Okay, sebab daripada side product tu kita boleh agak which reaction that we will use, okay, in this reaction. Alcohols also can undergo oxidation reaction. These are 3 types of oxidizing agent that usually used in the reaction. The first one is the acidified solution of chromate. Okay, so we have sodium dichromate, potassium dichromate, or chromic acid. Okay, and then we have acidified solution of permanganate, which is the potassium permanganate. Okay, kita dah pernah jumpa sebelum ni in chapter 5. Okay, last but not least, Pyridinium Chlorochromate. Okay, singkatan dia PCC, in dichloromethane, which is CH2Cl2. So for the primary alcohol, okay, so we know that on the carbon that bearing the OH group in primary alcohol, it got 2 hydrogen. Okay, so if you use a mild condition, okay, mild condition, if we use the pyridinium chlorochromate ataupun PCC in CH2Cl2 as our oxidizing agent. Okay, so the PCC, okay, PCC ni dia adalah weak oxidizing agent. So only one of the hydrogen, okay, that attached to the carbon that bearing the OH group will be oxidized. So that's why we are going to get an aldehyde. Okay, so primary alcohol in mild condition, which is by using PCC in CH2Cl2, will produce an aldehyde. Okay, but if you use harsher condition, okay, selain daripada PCC in CH2Cl2, which is the permanganate ataupun dichromate solution, dia adalah strong oxidizing agent. Okay, so if we have an primary alcohol, okay, a primary alcohol, okay, let's say here we use the sodium dichromate, okay, acidified hot solution, okay, it will convert it into carboxylic acid. Okay, so primary alcohol using harsher condition, okay, will turns into carboxylic acid. Okay, so the color of the sodium dichromate ni, color dia orange. Okay, since primary alcohol ada reaction dengan sodium dichromate, the orange color of the sodium dichromate solution returns to green. Okay, so kalau kita pakai potassium permanganate, the purple color solution of the potassium permanganate will become colorless ataupun will decolorize. Okay, for the secondary alcohol, since on the carbon that bearing the OH group, okay, so here, right, so we have only one hydrogen attached to it. Okay, so for the secondary alcohol, okay, hanya ada satu saja hydrogen attached to the carbon that bearing the OH group. So at any condition, alcohols will be converted into ketones. Okay, so tak kisahlah kita pakai harsher condition ataupun mild condition, kita tetap akan dapat ketone. Tertiary alcohol does not undergo oxidation under normal condition because on the carbon that bearing the OH group there is no hydrogen present. For summary, primary alcohol reacted with potassium permanganate, sodium dichromate, potassium dichromate or chromic acid, which is a harsher condition, it will form a carboxylic acid. When reacted with PCC in CH2Cl2, a mild condition, it will form an aldehyde. While secondary alcohol, at any condition, okay, by using any oxidizing agent, it will form a ketones, and tertiary alcohol does not undergo oxidation. One of the identification tests for alcohol is a Lucas test. So Lucas test is used to distinguish the type of alcohols. It means that for the primary, secondary and tertiary alcohol, okay, it will give a difference observation. The Lucas reagent is the concentrated hydrochloric acid in zinc chloride. For the primary alcohol, for example, here if we have 1 propanol, okay, treated with a Lucas reagent, there is no observable changes within 15 minutes. So the observation that we can get is no cloudy solution formed at room temperature even after 15 minutes. But for the secondary alcohol, okay, when treated with a concentrated hydrochloric acid in zinc chloride, okay, for example, here if we have 2 propanol, alright, so the cloudy solution will form within 5 minutes. So the OH group is changed into Cl. For the tertiary alcohol, for example, here we have 2-methyl 2-butanol treated with a Lucas reagent. Okay, the cloudy solution will form immediately. The second identification test for alcohols is iodoform test. Iodoform test is used to detect the methyl carbonyl group. So the methyl carbonyl group is on the carbon that bearing the OH. So this carbon must have at least 1 hydrogen. So it has a methyl group attached to it. Okay, so only primary or secondary alcohol that has the methyl carbonyl will give a positive results. So the reagent used for this reaction is an excess iodine in basic condition. So for example here, if we have a secondary alcohol, okay, so we have 2-butanol, Okay, so since here we have a methyl group attached to the carbon that bearing the OH group, okay, this carbon also got an hydrogen. Okay, when treated with excess iodine in basic condition, we will get a carboxylate ion. Okay, so kita akan dapat carboxylate ion, the CH3. Okay, CH3 ni akan keluar, kita gantikan dengan O minus, and then the hydrogen here will be oxidized into double bond O. Okay, and then the CH3 yang keluar ni tadi, it will become CHI3, which is our iodoform. So ini kita punya precipitate. Okay, so light yellow precipitate form for the observation. Okay, kita akan nampak light yellow precipitate form. For the tertiary alcohol, even though we have a CH3 group attached to the carbon that bearing the OH, since there is no hydrogen attached to the same carbon, so there is no reaction. So the observation that we can get is no light yellow precipitate form.